the other streams here. Cool. All right, looks like everything's good. Sweet. Alrighty, back to work. Where was I? Alright, so we're writing a task class. We were working on the, let's see, I think I was adding to the, public portion of the class. So let's go ahead and, okay, we already added this. That's already there. And what we'll do is we're going to cheat. We're just going to copy paste all of this crap. Drop it in here. That, my friends, is how you code. Okay. See here. I'm going to quickly scan through this. I say quickly, but it'll probably be really slow. Okay, my audio's working, camera's working. Wow. Cool. Okay, so we got a help me out here, guys. I need help. Okay, what's the explicit? I keep seeing this. I keep forgetting what this means. What is the explicit keyword? Whoops. I say whoops. It just scrolled down. Alright, C++, the explicit keyword used in your event loop constructor is a safety feature that prevents implicit conversions and copy initialization. Oh, interesting. Prevents implicit conversions. Since the constructor can be called with a single integer argument, the compiler would normally be allowed to silently convert an integer into an event loop object. What? It would be allowed to convert an integer into an... Okay. Oh, because it takes that type as a input to the constructor. Okay. Got it. That's wild. So prevents accidental logical errors. Without explicit, you could accidentally pass an integer to a function expecting an event loop. And the compiler wouldn't complain. It would just create a temporary event loop with that many events. Okay, interesting. And here's an example. If it's not explicit, so call do something that expects event loop, you pass it a number and it's fine. It's totally cool with that. That is very fascinating. Got it. All right, cool. Now we're clear. Going back here. Okay, so we're basically saying, hey, no implicit conversions, and what was the other thing? Sorry guys, let's see. And no copy initialization, okay. All right, got it. Okay, so what about this syntax? This colon, let's take a look at this. Colon handle. It's a member initializer. Oh, okay, it's just initializing handle. Okay, my bad. I should already know this syntax. Okay, so it's just a way to initialize handle. And it's going to initialize it passing in h from here, from the constructor. And what does it expect? Well, we can go look at handle. Handle is of type coroutine handle of promise type. So it's, I guess, coroutine handle is actually a template, which is cool. So it's nice and flexible. Let's see here. All right, cool. All right, so let's see. Here's another task function. I guess this is another constructor for task. Okay, so what was I doing? Okay, so it's gonna where am I at, guys? Let's see here. Okay, cool. So basically take a task. I think the double ampersand is a reference to a reference. What exactly is a R value reference? L value means left value, an object that has a name and a persistent location in memory. You can take its address using AND. Example, int x equals 5. X is an L value. Okay. Right value, a temporary value that doesn't have a persistent name. It's often the result of an expression or a literal. It vanishes at the end of the line. Oh, okay. Okay, or the example they give is like the int x equals 5. 5 basically disappears after it's processed and the value is assigned. Or the result of x plus 2, that result is assigned to something and then it no longer is existing. It just is assigned to, okay, to the L value. An R value reference is a type of reference that only binds to R values temporaries. We only had a normal, so in C++11 you only had normal references, now called L value references. If you tried to pass a temporary object to a function taking t ampersand, the compiler would complain because you can't have a non-const reference to something that is about to disappear. So they give an example, int double ampersand ref equals 10. That is valid. 10 is an R value. Int double ampersand ref equals x, error because x is an L value. Interesting. So you can't assign an L value to a, okay. Primary purpose of an R value reference is move semantics. Let's see here. When a function receives an R value reference like your task double ampersand other, it knows that the object other is a temporary or is no longer needed by the caller. This gives the function permission to pillage the object. That's an interesting term. Think of it like this: copying L value. You see a beautiful house, so you build an exact replica of it next door. It takes a lot of time and materials. Moving R value reference. You see a beautiful house, and the owner says, I'm moving out anyway, just take the keys. Okay, you don't build anything new, you just transfer ownership of the existing structure. That's an okay example, I guess. In your task class, the R value reference is what makes the handoff possible. Okay, so it's basically a handoff to basically just a reference to a value that is going to disappear. Because other is an R value reference, the constructor knows I can safely take other's internal pointer, which is handle underscore, and set its pointer to null pointer, and it won't mind because it's a temporary anyways. Okay. So I guess in essence, it's basically saying by assigning this handle to nothing to null pointer. Where is handle defined, by the way? Okay, so it's a private pointer or variable to a coroutine handler for the task. So it's a handle, it's its current handle to the coroutine. And it's basically just wiping it. It's basically setting it to null pointer. Okay. Very, very interesting. Okay, so there's an operator equals an operator function that takes in a task. If this is not equal to the current other, destroy it. That's an internal method on the coroutine. And then it will assign the other handle over to this one's handle, and then it will blank out other's handle, the other class that got passed in. Okay, so this is just a way of kind of like transferring tasks, one task to another. Got it. Just using a simple equal operator. Got it. Task, some task equals another task. It'll clear the old task, but also assign and update it to the new one, to the current one. The L value. Okay, so we've got a task, another task function. Okay, so we're actually saying, I think we're saying to delete the default task constructor that allows you to pass in a task by ref, because I don't think they want you to call this directly. Hey there, doggy. All right, let's okay, in C++, the line delete is a way of explicitly telling the compiler that the copy constructor for the task class should not exist. Okay, so you can't just do t2 equals t1. Why it's used here with coroutines. Task manages a coroutine handle. Coroutine handles are similar to raw pointers. They point to a coroutine state on the heap. If you were to allow copy of a task, both copies would hold the same handle. This would cause major issues. Yeah, I thought we were defining this operator here for that purpose, but maybe I'm misunderstanding the usage of this operator. Maybe it's not used in the same way as like a when you move it, the original task is nullified, ensuring that only one task object is responsible for the coroutine. Okay. We're also deleting the default, I think, the default equals operator. But it appears we also defined an equals operator here. Right here. But it expects a const of task. Okay, on teardown, we want to destroy the handle, the current coroutine. We want to call destroy on the current coroutine. I think the no discard is just telling the compiler to not ignore or get rid of this method. I'm just going to confirm that really quick here. Hey Dune, how's it going? Alright, let's see here. Okay, excuse me, the return value should not be ignored. Okay, so don't ever call this and just ignore the return value. Okay, so it's going to return the result of done, which is a boolean, when await ready is called. So that's going to get called done on the coroutine handle. Okay, and then if we look here, we're going to await suspend, which will return a coroutine handle given a coroutine handle. And then it's going to assign the continuation to the current handle. The coroutine handle promises continuation, and then return that handle. Interesting. I'll kind of understand that a little more with maybe some usages, just to see kind of what the purpose of that method is. It's not clear to me right yet. Await resume, so that will check if there's an exception on the promise, rethrow it, and then return and move the pointer, it looks like, to the value of the promise. Okay. Coroutine handle, promise type. That's our custom promise type that we defined as like a struct. Let's see here, and then I'll just return the handle. Okay, get the handle for it. Okay, I think that's it for that class. Oh wait, there's actually an explanation here from AI on the wait suspend. So it says it will store the parent and return let's see, return the handle to resume. Interesting. Yeah, I don't understand. Okay, I guess we'll find out when we get some usages of it. Alright, let's move on to the next snippet here. Let's see what we build next. Okay, let me see. Is this... I'm just reading through this just to kind of... I think I already did all this. Okay. It looks like we've got... Okay, I'm going to restructure this a little bit because it looks like I've done it wrong. Bear with me while I copy paste this in here. Oh, it looks like task is supposed to be void, except it doesn't like that. And what happened to our template? Sorry, I'm looking at a snippet here that looks wrong. Let me show you. So if you look here, it AI is basically saying that this is the continued snippet, but it got rid of like the contents for the template, the type name and everything. It just removed that, and then it decided to add this void tag here. I don't know why. I think that's actually supposed to be T. Excuse me. I think it's supposed to be T, not void. But it doesn't like that either. Let's see here. It says explicit specialization of undeclared template class task. I need some expert C++ people in the chat. Let me try asking this guy. I'm not sure. To me, it looks like it's the syntax is right, but maybe task should not have T. And then it should just be, let's see here, let's see what it's saying. Do I want you to read, let's see, read file. Yeah, go ahead and read it. Okay, missing final suspend. Add final suspend inside the promise type. Add this right after line 24. Okay, here's line 24. I thought I already had a final suspend somewhere in here, but this does not. It's inside the struct. And it's saying that final suspend member function can be made. Oh, okay, that's just a suggestion. Okay. The task void specialization needs to be added after the main task class closes. After line 83. Interesting. So I think that would be wherever the main class closes. So after this. After the semicolon? Nope. Alright, show me the full file. This is ridiculous. Okay, let's see here. What time is it? Okay, we're good on time. Okay, my audio is working, so that's good. All right. Alright, I'm gonna copy this whole thing and try to understand what in the heck I did wrong, because this is just throwing me for a loop here. Okay, so we've got a couple template definitions. I think I need to get rid of one. Or is that how the sample shows? Okay, yeah, I guess I don't know what I'm doing anymore. Let's see, so we got template type T equals void. I don't know what type T void equals void is. Type name, excuse me, type name T. I don't know why it would be equal to void, because if it is a template parameter. Thank you for scrolling. When you see this inside a template definition like this, it performs two main rules. Thanks for all the headers. The type name T part tells the compiler that the class or function following it is a blueprint. Thank you, I'm aware of that. T is a placeholder. Okay, void is the default type. Okay, so you don't have to actually, okay, that way you can create this kind of task without specifying a type. Okay, got it. And then we've got another template type named T. Yeah, I don't understand why is template type name plus class task specified twice in the header. I don't understand this syntax. I don't know why you have to specify it twice. Okay. One is a defining of the default argument. It can only be specified once. So you want to put the default once first. Then the actual, okay, separating the signature. So it's a kind of like a signature from the actual implementation. Got it. All right, fair enough. And then let's go through here and let's clean some of this up. Initial spin can be made static. I don't think that's an issue because it makes no reference to the current instance. I guess same with final suspend. Await ready can be made static. All these things are just static. Okay, so we got this struct here. I don't even know. I didn't know you could just inline a struct like this inside of a what appears to be a method. And then I guess you just return the struct. It's very interesting syntax here. Let's see here. Await suspend can be made static. Is there anything else that should be static? Is there anything else in here that's wrong? Let's see, make member function const. Wait, what's going on here? So make member function const. Does that make the function? What's immutable or what's it making constant? Let's see, is a crucial part of implementing symmetric transfer in coroutines. It's with an awaiter, in this case the task. Let's see the method signature, blah blah blah. I want to know about. I selected const, like it's not saying, there's literally nothing in here that I see that's talking about const. Wait, where's const? Am I blind? Probably. I'm not seeing const in here anywhere. I literally just wanted to know why the keyword const on this method, or I think it was this one. Alright, let's see why the const keyword. Maybe you can finally answer my question after you scroll me down to the bottom of the page. Okay, never mind. In this specific code, the const keyword allows you to co-await a task even if you only have a const reference to it, or if the task is an R value temporary. being treated as const. Enabling co-await on const tasks. When the compiler encounters co-await expression, it needs to call await ready, suspend, etc., resume. If expression results in a const task, these methods must be marked const. Otherwise, the code won't compile. If await ready is const, it's idiomatic to make await suspend const as well, so that the entire waiting workflow supports const task objects. If you look at your task, the non-void version, your task template, await suspend actually lacks the const keyword. This is an inconsistency in the provided code. The specialization of task void has it, but the primary template doesn't. Usually you'd want them to be the same to ensure consistent behavior across all task types. Adding the const to both is generally preferred for maximum flexibility. That made no sense whatsoever to me. I think I'm going to go with the initial explanation that it allows you to coroutine await a task even if you only have a const reference to it. So it's enabling the method to be used or called on the task even if it mutates the inner variables of the class. Those methods are allowed to be called, and the compiler will compile that code even if you define the task as constant. Okay. All right, so let's just go ahead, mark this as no discard. This one can be const as well. It just seems odd to me that these methods are all just, I guess because these methods are not actually needing to be, let's see, let's take a, like, await resume. Okay, how do I go to definition? Go to, okay, control B. All right, how would use that? Oh, I gotta do I have to highlight it? I guess I can't. Yeah, I think I need to fix my hotkeys because I can't jump around. Okay. So there's one definition of, let's see, that's one definition of wait resume. And then there's another one. Why are there two public sections on the same class? How many class tasks are there in this header? 3. Okay. I think the confusion for me is that we actually have we're actually defining, there we go. Okay, so we've got this is C++. All right, so we've got a template that signature, I guess, for the class task, saying that it can be it defaults to void. That I understand. That makes sense. We then have a definition for a class task when a type is specified for the template. Then we use this class. If we don't specify a type, we use the other class. Now, I think all these classes are defining the same methods. The difference is just some of the typing. Okay. I guess let's try working through the type, the initial. Okay, we know what the promise type is. I went over that in my stream that died on me. So we have a value, optional value for the promise, or potentially an exception or a continuation, which is a coroutine handle. I assume this is nested promises, where you have a promise that resolves and triggers yet another promise. I don't like that style of handling of promises, but I guess this does support that if you want to use it. Then we have some supporting methods that do things like initial suspend, do nothing. Matter of fact, if I recall, I think that when I looked this up, I think the AI's explanation for this was that it can get ignored by the compiler, or when it goes to use this promise type, it's going to try to call this, but I think it'll tell it not to call it. Okay, so it's a mandatory function that has to be defined, and the compiler generates code that calls initial suspend. Okay, that's now it's coming back to me. So by returning the type suspend always, we're saying don't execute it right away. Don't execute this promise. Final suspend. I don't know what that's for. Determines what happens to the coroutine state when the coroutine reaches its end, either by executing coreturn or falling off the end of the function. And internally it calls await ready for some reason, I guess. Wait, no. It returns a struct with a final awaiter, which apparently will return a continuation if it has one. Otherwise it will just return this do nothing, no op coroutine will be returned if there's nothing to be continued. And then it provides a await resume method. Okay. So why it returns a final awaiter, I'm not entirely clear. I feel like this is stuff that was defined. Okay, so it's defined on the parent type. Okay, so I guess when it calls final suspend, it expects this kind of final, like, implementation of its expected functions, which it's going to check when it's done, when that promise is completed, I guess. And then it might call return value, I assume. That's my guess. And then it returns the value. Okay, so we are... There we go. I just had to indent that. Cool. Moving on. What a interesting way to define classes in C++. There's a lot to it. In this case, we have, just to, for my own sake, I have to kind of quickly review this, but we basically have a signature template type name defaulted to void, and then a class named task. So we're telling the compiler that that's the name of the class, and it can, if it, the type is optional, and therefore if you don't provide a type, it'll just be void. Then on top of that, you have to define the implementation or the header for both class types, for the class where they pass a type and when they don't pass a type. And that way you can have different method signatures and implementations. What's really odd to me, though, something I'm kind of wrapping my head around, is the difference between header and the source for the class. What's confusing to me is it seems like the header is implementing some of the functionality for the class, and I thought the header was usually just kind of almost like an interface, like declaring here's the name of the class, here's the shape of it. Excuse me. But what I see instead is I see kind of like I see more so like you're actually defining functions and implementation, or at least some implementation details. So I think we can look at that later, but I'm just trying to kind of wrap my head around this because I'm sort of catching up on years and years and years of not having touched C++. Okay. Now, let's move on to the next step here. We're vibe coding now. Okay. Let's see here. Oh, well, okay, that clears up my confusion, I think. Task CPP is not needed. So task T is a template class, so all implementation must be in the header. Wow. If the compiler needs the full definition on at each instantiation site, the CPP file would only be needed for explicit template instantiation, not needed here. Non-template helper functions, we don't need any. Interesting. Non-template helper. Oh, okay. Skip to awaitable header. This is where we define primitives like FD awaitable, suspend until FD is readable, writable. Sleep awaitable, suspend for the duration or for a duration. And then ready awaitable, yield to event loop, then resume. Okay, before I create that, let's delete the excuse me. Let's delete the task CPP file because we don't need that. And then let's create our awaitable header. Let's put that in the same folder. Wait, what's the name of that? Awaitable.h? Do we need a... Yeah, I don't know. I'm just going to go... Okay, I'm just going to create the individual header file for now. And then we'll do awaitable. And then how dare you use this old, outdated if in def. Just use pragma, bro. Okay. Let's continue on, and then all right, so I'm going to drop this usage in there for posterity's sake. And then of course I'm going to comment it out. All right. Oh, come on. Come on, AI, you screwed up. Oh, okay, never mind. Maybe not. Maybe not. Maybe not. Give me the next one. We'll just read through it. I don't need to hand type it all. Feeling lazy today. Feeling lazy. Don't really want to type. Okay. Another struct. Usage example. What was our previous thing? It was try to keep these organized. Okay, and then okay, so wait suspend registers the file descriptor with event loop, suspends coroutine. Event loop detects the file descriptor is ready. Queues coroutine for resumption. Interesting. So await suspend registers the file descriptor with the event loop. It waits for it to become ready, queues the coroutine, and then await resume. Interesting. retrieves what events triggered, unregisters the file descriptor, returns events. That part I don't understand. Why it only returns await resume is going to like get rid of the file descriptor and then return the events. But we're gonna hopefully figure that out. Alright, moving on. I hate half undone what? Okay, let's see here. Okay, I got this sample. Let's see, purpose voluntarily suspends, immediately reschedules, prevents a single coroutine from hogging the event loop during CPU intensive work. Interesting. Alright, let's walk through this little by little. Alright, so we've got a struct, sleep awaitable. I see all the same exact methods I could have swore I just saw here. Await ready, await suspend. I don't know why we're doing this again, but hopefully it'll become more clear. Sleep awaitable. So it's going to return whether or not count of the duration is less than or equal to 0. So that will result in true or false. So if the count is less than or equal to 0, then it will be true. Let's see here. Await resume is just does nothing. It's just providing a method that I guess it assumes doesn't need to be called. Okay, sleep for, and then you pass in some milliseconds. Sleep awaitable. So it returns a new sleep awaitable, I assume, and then it basically just gives it a duration. Oh, thank you. All right. Let's see here. Okay, sleep, and then this is going to return type sleep awaitable, and then I guess that'll give it a kind of a promise coroutine promise type with methods to check if it's the timer, I guess, is finally ready. Sleep for, okay, we just looked at that. I don't know what inline does. Let me look that up really quick. While I wait on that. Just keep scrolling through here. We've got an FD awaitable, file descriptor awaitable. Oh, it gives us a usage here. Okay. Co-await sleep for X number of milliseconds. So coroutine await, and then it's going to sleep it for 100 milliseconds. It'll start that task in 100 milliseconds, I assume. Interesting. Okay, let's go on here. Let's see what it says here. I want to know, okay, this keyword suggests to the compiler to replace the function call with the actual code of the function to reduce overhead. In modern C++, it's also commonly used to allow the function to be defined in a header with the file without causing multiple definition errors during linking. Interesting. Okay. So it allows the compiler to literally put this function into the actual code. It's also used to allow it to be defined in a header so that it doesn't cause multiple definition issues. Okay. All right, moving on. So FD awaitable, let's see, the constructor does not initialize these fields. FD and events. Okay. We just basically have to set them to something. Okay. Fair enough. Okay, and then let's see, this can be static, const. Alright, so again, await ready is just false. Up here, this one is false until count is less than or equal to 0. This one just defaults to false. Get triggered events, and then what does it do with that? Okay, it returns it as an event type, enum, and then it calls, let's see, event loop current unregister FD. Okay, so, oh, that's what we were reading earlier that I was wondering about. Okay. So it resumes, and then it basically gets the event flags and then returns them. Interesting. I don't know why it removes it or unregisters the file descriptor. I assume something is going to try to process it again, so it'll re-add it, maybe. Or it's just done when it calls this, and then it basically is just it's complete, so it's just unregistering it and getting the current flag, current status. Okay, so let's see here, FD waitable. Let's see here. So this is an inline, so I guess the compiler can just drop this code, compile that code right in place where it's referenced, and also it'll keep it from having multiple definition errors because it's not actually defined like as a named function. It's actually just the lines of code are actually inlined into the place where it's referenced. So there's no naming issues or conflicts. I see it's probably going to say that FD can be const. Yeah. I don't know why AI is kind of dumb about this. It doesn't really seem to realize that these are not being mutated in any way or like changed. Okay, so let's see. Wait readable. So it takes a file descriptor, returns a new instance of FD awaitable, and then basically sets the flag to read. I don't know why it's doing that. It doesn't really have a defined constructor, so it's just literally assigning the events in the file descriptor. So it's just giving it a new instance. Wait readable. Get me a new instance of FD struct, awaitable struct. I guess I don't know if you can do. I think we just did that here. I think. Oh no, these are not. The task is a class. It has an internal struct, which. Yeah, there's no constructor. I don't think structs can have constructors. Okay, struct FD. Okay, so it's just creating a new struct with these values. All right, got it. And then wait writable, create a struct with the flag set, the events set to write. Again, this could be const. This can be also const. Yeah, it's just dumb. I don't know why it doesn't use const in the sample code. Okay. Sample usage. We create a task of type void. Read when ready. Okay. Some function called read when ready. We get a socket file descriptor, and that's from the OS. And then the, let's see, event type. We await wait readable given the file descriptor, and then we get the events. Wait a second, so that's not what I understood. Oh, the result of the file descriptor waitable is what we actually get in response. But the FD waitable is basically internally it is a promise. And I think when it resumes, it's going to give you, so it's going to give you the event type enumerator as the result. And so then you'll get an event type or events, multiple event types. And then it's going to check, do I have the read event? And now I can read it. That's simple, yet confusing because I think the piece I'm missing here is I thought task was necessary to all this, and I don't see. Oh, hang on. Let's go back to our example. Okay. Here's where task is being used. I think what we're doing is is this a method on task? No. Okay, I guess it's gonna return, I guess you have to return, I guess the function has to return task if you use co-wait. I don't know. That piece I'm not really sure of. Alright. Let's see here. So await ready, clean tidy function. Await ready should be marked as no discard. Okay. Also, what else? What am I missing here? I want to cheat. It can be static. Yeah, I knew it. And this too can be static. Okay, we don't need the no discard, I guess, because it's static. Alright, all done. I'm calling it a night. Thank you for watching, if you're watching, and have a good night. And I am going to get some rest, and we'll see what I do tomorrow, maybe. Catch you later. Thanks.